Good morning, everyone. Welcome to my talk from Trust Me to Verify Me. And when I made this talk, and when I'm going to introduce myself a bit later, when I made this talk, I was actually a bit scared of the things I found as well. So I hope to not scare you that much today, but hopefully give you inspiration to make the world a bit safer tomorrow or the day you start working again. So we live in a world where we tend to trust a lot of packages that we use, right? We pull in a lot of software, we deploy to production, and we trust the authors of those packages, of those software that we deploy to production. Looking at recent history, the attack vectors of our applications, which where hackers try to access our applications via the front door, right? Trying to do SQL injection, that kind of stuff, still exists, but the attack vector moved a bit. Right? A great example of this was back in 2020, where the SolarWinds attack occurred, which was a data breach in the US federal government. It was caused by a malicious action that was injected in the Orion software of SolarWinds, and it was injected in that software via their build platform. So no developer was harmed, no software was harmed, it was just in the software that was shipped to the US government, and it was exploited when it was in place. Right? Really scary stuff. Back in 2020, it was the first publicly documented breach via a supply chain attack. But if you look on Google News or any news site that you're on and you search for supply chain attack, I did it yesterday, for example, June 1st, some kind of supply chain attack in the Red Hat NPM packages. Right? Red Hat is kind of a big organization in the open source software. Might be that you're using some of the packages that they provide or they ship to you. It might be that since 2 days you're compromised. Right? Just not scaring you, but something you might have to look into after this talk, or maybe during the talk if you're that scared. Or it's more like 8 days ago, over 5,000 GitHub repositories got infected by a supply chain attack, with the sole purpose of extracting CI secrets, environment variables, all kinds of tokens, all kinds of secret information that you have in your supply chain that you use to build your software, where attackers can make misuse of. So real supply chain security only exists where consumers can independently verify the producer's claim. So the stuff that we're pulling into our software, we're deploying to production, we need to have a verifiable way to verify the claims that they are making. We are the creators of the software. We make sure that there are no harms in there. We are you can trust us, but it's better to verify the claims that we make. So we're going to discover that in this talk. My name is Tom van den Berg. I'm a lead engineer for a company called InfoSupport in the Netherlands. I'm a tall Dutch guy going to struggle around with this bit too low stand for me, but that's okay. And we do all kinds of projects for large companies in the Netherlands. I'm currently employed at the Dutch Railways, where I'm a lead engineer for the mission-critical platform. So I'm responsible for all the infrastructure, the entire platform that our developers are using to create the software, deploy the software, and run it on production. So this is a subject that goes me by heart. I tend to do a lot of research, experiments in these kinds of directions to make our platform more secure for our users to actually use. So looking at your software supply chain, it encompasses all the materials, resources, and processes that are involved in producing and delivering a product. What's more important than that is that software that you deploy to production is no longer entirely written in-house, right? We're not creating Entra ID integrations. We're not creating database integrations. These are packages we pull in. There are tools that we use, Argo CD or any other tool that you use in production. Stuff we don't write ourselves, but we deploy it in our trusted environment. We allow it to do certain actions in our environments. And that's quite scary. Looking back at 2022, there was this research that was done about how the world relies on open source software. And the results of that were quite scary. If you look at the results, there was it's somewhere in between 70 to 90% of all the software that's deployed in any modern solution is based on open source software, which means that someone else wrote that code, which means we blindly trust, in the worst case, 90% of the software that we deploy, we blindly trust on Microsoft, Red Hat, all kinds of organizations to do the right thing. That's scary, right? 90% of the software we deploy. So the stuff that you write on a daily basis is just the top of the iceberg. I really like this picture. I'm not sure, maybe someone have seen the steady one that was straight. AI made a nice version of that as well, which you can find on the internet. But there are all kinds of dependencies in our entire tree, right? On the bottom, there's the C cable stuff where Richard tends to talk about sometimes. Whatever Microsoft is doing, all the stuff that's happening on the web, and everything in there encompasses your supply chain. And what happens if one of those bricks get a bit tangled with, right? What happens if there's something in there which you shouldn't expect or which you don't expect there to be? So going one step back, what producers of software can do to create the claims, or at least make sure that we can, as a consumer, can verify that the stuff that we pull in is actually theirs. They can sign artifacts, right? Artifact signing is not really new. It consists of 3 different steps. So at first you need to have some kind of artifact. An artifact can be a Docker container, a WASM module, Terraform modules, anything that you can think of as an artifact. It has a certain type of path. So in this case, it's pushed to a registry where I have the path to my image based on a tag. I'm using a private key to actually sign it, where I say, hey, I'm the author of this product. I'm giving my digital signature on this product and say, hey, you can trust me. I'm a trustworthy person. I'm the one who produced this software. And that's being pushed to the registry as well as a signature. And then this is something that you can verify. So artifact signing is a rather simple aspect, yet people tend to do this wrong sometimes. Because there are 2 ways that artifact signing can work. There are 2 different ways in the registry that you can identify an artifact with, which is based on the tag or based on the digest. So looking at the tag, if you do signing based on a tag, you actually say, hey, I trust whatever artifact is currently referenced by this tag. What is important is that the currently referenced section, which means, taking one step back, why would you do artifact signing based on a tag? It's easy human readable, right? We can understand 1.0.0. Everyone knows a bit about that. And it fits in the release process that we have, right? Major, minor patch updates. Who's not using something like Semver or to publish anything they create? Right? Everyone uses it. I'm using it as well. And you can use that tag to sign. What's the scary part of tags is that they are mutable. So today, my 1.0.0 version is trusted. I can sign it, and tomorrow, some kind of attacker, hacker, whatever person can upload another artifact with the same tag and just re-tag my artifact. So trust based on a tag is not a very good idea. That's also why you see in, for example, CI/CD actions. Anyone who uses GitHub Actions? Great. Who's using a tag to reference some kind of action they are pulling in from the outside? Right. Honest, thank you. Great. That's actually quite scary, right? A tag can be rewritten, can be retagged, and you might pull in something entirely different than you did yesterday. So that's the scary part of it. By tagging or signing based on the digest, you're actually saying, I trust this exact content. A digest is a SHA-256 generated hash based on the content of your artifact. So if the content of your artifact is changing, the digest is changing, and then you need a new signature to prove that you're actually the publisher of that artifact. Right? So if you do signing based on a digest, you create a fully reproducible artifact that you can sign each time, and it has the same output each time. So looking a bit more detailed in this, so let's say we have this artifact in the registry. There are 3 things that you need to sign. You first need some kind of tool to actually perform the signature. The de facto standard in the world, as far as I know at least, and the stuff that I'm using daily, is cosign, which I'll show you in a bit. And cosign is a tool that creates the signature for your artifact. Cosign needs some kind of information. In the first page that in the first image I showed you, there was some kind of private key which is going in there. Cosign allows you to bring your own certificate. So we as a company for the Dutch Railways, we have our own private certificate that we use to sign the stuff that we build. But the stuff I'm going to show you today is called Fulcio, which is a additional tool next to Cosign, which allows you to temporarily create certificates based on an authority to use that to sign. And then the third part is that there needs to be some kind of system of record. So there needs to be some kind of evidence that is verifiable that this signature was made, right? A tool that's used for that is it's called Recore, which is a public tool. It's cool and scary at the same time, because when you create a signature, a record is pushed, right? We want to verify that record. But on the other hand, attackers can also see, hey, there's this new signature that was made, and it's publicly available what the record is for that. So you also, if using a public tool for this, also gives a lot of information away. So let me see. Let me first show you, and I have to stand a little bit awkward, so sorry for that. Azure Container Registry, people who have not seen Azure Container Registry before, right? It's an OCI registry that can contain images that you can push there and pull from. Right, I've pushed my latest thing, which is not a great thing to do, but let's keep it for this demo at latest. And what's important to see is that there's this manifest and there's this section called referrers, which we'll dive in a bit, but there's nothing here, so that's what's the most important thing. So I'm using Cosign for this, and with Cosign I'm actually saying, hey, I want to sign this specific image, which references, is this readable for people in the back as well? No? Okay, I'm gonna zoom in a bit, try to zoom in a bit, and hopefully keep it readable for myself as well. Move this one away, move this one away. Is this better? Great, thank you. So I'm gonna say Cosign sign, and then I'm gonna make a reference to my, the artifact I have in my registry. And then I say, hey, I want to sign it based on the SHA, right? The digest I have in there. An error command, I'm unauthorized, which is good because I was expecting a pop-up. I'm sorry, I think I need to log in again. Which 5 minutes before this presentation started I did, but sometimes they log me out. Okay. Let's see if I can do it again. Yeah, okay. It found it. It says, hey, do you want to create a new system of record? And it says, hey, do you want to create, use Fulcio, right? The public stuff for the public authority to create a certificate. And I'm now saying, hey, I want to create a certificate based on my GitHub login. So I'm now doing this as a person, a personally assigned certificate for me based on my GitHub account that I'm going to use to sign. Great. So signing actually succeeded. It doesn't give you much output of that, but going back here is now I have this site store bundle as a refer. We're going to dive in this a bit more, but for now the stuff that I want to show you, and there's a lot of hashes and stuff in here, so I'm going to copy and paste a bit. So the first thing I can do is I can actually download the certificate, which has a lot of information in here. But what is the... I really needed my mouse for this. Let's see if this works. I'm doing all kinds of magic, sorry for that. But what I'm doing is I'm downloading the certificate of the stuff that I just did, the signature I just made. So I can actually show you the stuff that's being created. I'm going to zoom out a bit for it. So my site store bundle, it has all kinds of entries and all kinds of proof. But what's important here is this, this identity, which is the identity of the record that was created in the record database. So if I go to the record API, which is here, I can actually say, hey, give me all the information about the signature that was just made. Right, and here you can see that it's all encrypted, and I'm going to show you in a bit what the content of it is. But it contains the signature that was used, or at least the public key of the authority that was used to sign this artifact, the time it was made, and all kinds of stuff. So going back to what you should be doing with this information, and now I've pushed it to the registry, and as a consumer I can say, hey, I want to see some metadata out of it. And here I can actually see, hey, it was the OIDC user, issuer, that was used to sign the certificate is GitHub, which I did because I logged in via my GitHub account. And this was the email. This is the email address of the user that logged in. So now I have some verifiable evidence of who at least created the signature of this artifact, right? It's the first easy part that you can actually do. What you can then do is actually say, hey, cosign, I want to verify this artifact, and I want you to check if the identity that was used is this identity. Well, now it's mine, but you can imagine, for example, if you're a company who publishes packages, artifacts, or whatever, you have your name as a company here as well, and then also the issuer of it, which is the bare minimum of stuff we can actually see and say, hey, the checks were performed and the verification actually succeeded. So this is the bare minimum of stuff what we can do currently, which is not rather new, I hope, for people. And what I'm going to do now is remember the stuff that was just in the registry. I'm just going to run this workflow and then continue back to my presentation. Otherwise, I'm not going to wait for this. So, cool. Right. We've now seen a rather simple example of publishing an artifact, which I already did, signing and stuff. Maybe has anyone who's not using cosign currently to sign artifacts they publish? But some people, about the half of it, so people know about this stuff already, right? If you're not, definitely have a look into it. What's more scary is that this can be forged, right? I showed you the first stuff where people are extracting all kinds of CI secrets and all kinds of signatures that are via NPM packages and all kinds of other Red Hat stuff that's pulled into the pipelines. People are extracting, for example, that private certificate that you use to sign your image with, right? We need to have more verifiable evidence to make sure that the build or the artifact that we're pulling in is built from the sources that we expect it to be from. One of the attacks people actually use is, for example, a stale branch attack. Right? People tend to forget they have this certain test branch or an experiment branch where some feature or old vulnerability is still in, but yeah, we're not using that anymore. Who does clean their stale branches properly? Great, a few people. Most of the people don't clean their branches. So if you go back to your project on Monday or whatever you're going back to, please have a look at all the stale branches you have on your PC that you do not push accidentally, but also the stuff that you have on your remote, right? If you see what kind of branches are still open that are maybe open for longer than 6 months, 7, 8 months, it might be that you want to clean them up. Because they can be misused, right? For example, bypass review policies. Mainly, most of the projects I've seen this far is the main branches protected were quite good, right? There are all kinds of PR checks and all kinds of pipelines that you need to run. But those policies are not really for other types of branches, right? Experiment branches. So I can bypass the review policies, merge certain stuff in, for example, a nightly build or whatever. Reactivate vulnerabilities. So what if my stale branch still has this reference to the old version of Enter ID or .NET or whatever you're using, and where there's this vulnerability that I want to exploit? Let's reopen that branch, create a version of it, and we might be able to reactivate the new vulnerability. Reuse approvals, which is a scary thing, I think. What's even more scary when I did the research is the confused deputy. Who's using Dependable to update their... Great. Have you heard of the confused deputy attack before? Great. So there's this thing which is called Dependable recreate, and that's something that you can say in the conversation or in the issue that you have on the pull request, on the pull request itself. And with this command or this few words of text, 2 words of text, you tell Dependabot to recreate a pull request. Right? It's not really that scary. But what happens if that the Compuse deputy is all about having a trusted party, Dependabot. We trust Dependabot to update our stuff, and if the pipeline succeeds, we auto-approve and we merge it in. Right? Stuff we do. But we can trick that in doing unintended actions. So let's dive a bit more in this. Let's say we have this repo, my repo, where I have Dependabot enabled, and I have this workflow that says, hey, if there's a minor patch or a minor or patch version update, I just want you to auto-merge it in. If the tests succeed, it's okay, right? Cool. Let's say I'm going to fork this one. I'm going to fork this repo, and I'm going to inject some malicious code in it. I'm going to enable Dependabot on my branch. And then I'm going to create, me as a user, I'm going to create a pull request back from the fork back to the original repository where I created that fork from. Right? The author of that pull request is me, the malicious actor, in this case. And what will happen is the pipeline, the workflow will run, and it says, hey, you're not that deputy creator, you're not Dependabot, so there needs to be some kind of approval before I can merge this in. What you can then do is in that pull request that you create from the fork, actually say the 2 magic words, Dependabot recreate. And what it will do is Dependabot will recreate the pull request, change the author of the pull request, and then if you have this stuff in there that says, hey, if there's a minor patch update, just auto-approve it and merge it in, you'll actually be able to misuse this. Put malicious code in the software by just simply the fact that people are using Dependabot. That's scary, right? Cool. So, to make sure that these kinds of things don't happen, we need to have some kind of standardized trust between producers and consumers. The Open OSSF, the Open Source Security Foundation, adopted the SLSA framework. SLSA is pronounced as salsa. It stands for Supply Chain Level for Software Architects, and which it doesn't really consist of a technique or a tool or whatever. It's more of a vocabulary. So, talking about the same words when we say certain stuff. It is a set of guidelines and a set of checklists that you need to have in your supply chain to reach a certain level of security. It's based on the entire software development lifecycle, so from the producer to a consumer perspective, where it states something about how you build your artifacts and how you store your sources. So there's the one track that says, hey, I have a certain opinion about how you store and secure your Git repositories, for example, the main branch and all the stuff that's on there. And the other track, and that's the track we're mostly interested in today, is about how are we building artifacts, how are we publishing information about these artifacts, and that's what we're going to dive into a bit more. So SLSA defines all kinds of things, but one of the things they do is they define the implementers. There are 2 implementers that are mentioned for producing an artifact, which is the producer, which is me as a person, our team, our company, something that is producing an artifact. And on the other hand, what's really important, what people tend to forget, is that the build platform that you choose also has a significant impact on how an artifact is built. So for each of those implementers, they have a certain set of requirements that you need to have to reach a certain level in the framework. So on the first, as a producer, you don't have much choice. If you choose correct things, you can get on level 3 quite easily. So if you choose an appropriate build platform, and we'll come back to the build platform in a bit, consistent build process that have a reproducible build process that has the same output every time, and you need to distribute something which is called provenance. And provenance is the main subject of this talk, which we're going to dive into. So the build platform that you choose to reach the highest level has a certain degree of requirement that it has. So provenance generation, it should exist, right? Exist is the lowest bar that we can set. You should have, in some shape or form, have provenance. The provenance, if it's authentic, then you can reach level 2. And if it's unforgeable, which means it's signed and in an authentic way, then you can actually reach the highest level. And there's also some stuff about isolation of the runners that you used on, right? The hosted runners are more or less more vulnerable than when you do it in an isolated environment, but that's not something we're going to talk about. So what we do want to dive into a bit more is the build provenance. So build provenance is verifiable information about software artifacts, describing where, when, and how something was produced. Which means that looking at the build process, there are all kinds of stuff that are going in the build platform, happening in the build platform, and then coming out of it. Right on the left-hand side, we have, for example, the build type, which consists of what type of build platform is used. I'm going to use GitHub in my demo here, but for example, Azure DevOps is one of them as well. There are internal and external parameters, where the internal parameters are defined as trusted, because they're handled by the build platform. You can include them in your provenance as well, just to make sure that if someone wants to reproduce your build at a later point, they know which type of internal properties are used. External parameters are the most dangerous ones, I think. These are the things that that describe, hey, what type of public key is what type of key is used to sign certain stuff, what type of environment variables were in there, what type of all the external stuff that we put in our build environment to make our build succeed. So the dependencies that are resolved are also in there. So which actions are being used in our build environment. And in the end, the output that's being created and the based on the subject, which points to the digest we saw at the beginning of the presentation. So this file is generated, and for example, GitHub has claimed, and I'll show you at the end of the presentation why it's not actually, but they claim to be at SLSA level 3. So the build platform creates authentic, unforgeable build provenance, right? That's an important thing. Azure DevOps doesn't, right? Who's using Azure DevOps? Great. There is this, let me show you. There is this Azure DevOps demo of the SLSA framework, in which they state themselves, hey, we can only reach SLSA level 1 in this case. So even if you wanted to adhere to the highest level of that SLSA defines, if you're using Azure DevOps, it's not the correct build platform according to the framework. Going back to this. So a second thing that you need to have, so we have this build provenance, and in some shape or form, we need to distribute it to our consumers, right? Consumers need to have this provenance in hand to verify against which version of the software, which branch it's being built from, what triggered the actual workflow, all kinds of information that you want to have as a consumer to verify, hey, I trust this artifact. And to do that, you can create an attestation for that. And attestation is also a definition which is in the vocabulary of the SLSA framework. It's an authenticated statement about software artifact or collection of software artifacts. And with authenticated, it means it's a signed file in this case. So it consists of a couple of things. It consists of a predicate, and the predicate is actually something that defines some kind of metadata about the actual artifact it's pointing to. The subject is actually pointing to the actual artifact. So the predicate contains metadata about what type of, is it, for example, a SLSA provenance file, is it a bill of material, is it all kinds of stuff that I'll show you later what the possibilities are. The subject that points to the digest, this part of a statement which is part of the message, and in the end you can have an entire bundle of attestations. Another de facto standard that I see a lot, at least happening, is the in toto format, which is a format of an attestation. And here you see again the predicate, which defines, for example, the type and some kind of metadata about the version that's being published. The subject that's being used that references the digest, and it's all part of the envelope. So I triggered my build pipeline before I switched back, and I'm going to show you first how it looks like. So this is a build pipeline that builds my application, pushes it to the registry, and then creates build provenance for it. First, before I'm going to show you the content, I'll show you how it looks like here. So when I refresh this one, you see there's this new version here, which has 2 referers now, right? The first time I created the cosine sine thing, it created the referer here, which only says, hey, there's some kind of signature made on this artifact made by this user. Now, if you open, there are 2, and there are 2 because on the one hand side I generate build provenance, and on the other hand side I create something that's called a bill of material, which is not important for this talk, but that's also being attested to my container. So they are connected to my artifact as a reference, which I'll show you in a bit. But the cool thing is when I download this one, for example, and then I'm gonna move this a bit, and I need to do some magic again because it's all hashed and base 64 encoded and all kind of stuff. So let me see. There's this envelope which contains the content, the payload of my build provenance. And if I do some stuff that you should never do, but just copy paste it and put it in here. Oh. Cool. So this is a build provenance file. It contains the subject. It made a reference to my artifact, right? The name of the artifact and then the specific digest that I'm using. So this is the reference that we have here. And then there's this predicate, and this contains the build definition. So I'm using, in this case, the GitHub Workflow v1 version. The thing I actually built is, I built a main branch from this repository, and the stuff that actually built it, the workflow, is identified here. So here it already tells you more information about, hey, what sources or what workflows, what information is being used to create this artifact. If you go a bit further to the internal parameters, for example, I say, hey, what triggered this build? And you saw me manually trigger this build, which is the workflow dispatch thing. But for example, if you go back to the confused deputy attack, you can imagine that the trigger is something like a pull request merge, right? And you can say, for example, I will never allow an artifact in my project that's solely released by merging a pull request in, right? It really determines on how a project is consumed or is produced, and actually really depends on each specific project has their own way of work, which you need to know to verify if it's done correctly or not, which is hard work. So I'm using here the GitHub hosted ones, dependencies that are resolved, and even references to the stuff, the runs that are being used, the run that was being used. Yeah. So this gives us more information about the artifact that was being built, how it's being built, what resources are being used, the parameters that were used there, so we are able to reproduce it and make sure that each time we build it, it has the same output. So how is this? You saw me at the reference were there, right? The one hand has the digest that refers to the others, and in the OCI registry you saw that this reference in here, right? When the manifest itself, and then I have these references here. This is all possible because of something which is called an OCI artifact. So, for example, Azure Container Registry is an OCI registry, which is, stands for the Open Container Initiative. Originally, this was built for containers. right? We're pushing container to a registry. When you push something, you don't push it as a whole. You push certain layers for it. It has a digest and all kinds of stuff. So it has a manifest, layers, the digest, the media type. And something that's in there is the reference. And the reference is quite a cool thing, which is now being used for example, connecting your signature to that manifest. And the same thing that you can do, for example, the SBOM file or the build provenance. You can upload it to your OCI registry and then create a reference to that artifact that's actually belonging to, and then actually sign that reference as well. But what's really cool is that I started this talk by saying maybe you have some WASM module, Terraform modules, any other machine learning module, anything that you can think of that you want to distribute as a producer to your customers. Does this work as well? There's this tool called ORAS, and has anyone ever heard of ORAS before? Right, one person, great. ORAS is a tool that allows you to actually create an OCI artifact out of almost any type of resource that you can think of. So, for example, we as a platform team create certain Terraform modules that are used by our platform, by our workload teams to deploy databases, for example, to make sure that we distribute it in a safe manner and people can verify that we are the producers over it. We create an OCI artifact out of that Terraform module, sign it with our own team key, and then teams can pull it from there and verify, hey, is this module actually signed by the platform team? And then we trust it, otherwise we won't pull it in. So let me show you a quick example of ORAS. I have this markdown file, which is, I think, the most simple example that you can give, but okay, it's for the idea. It's just a simple markdown file which has some text in it, and something I can do. You don't want to see me type all these kinds of stuff, so which I prepared some stuff. I can actually say, hey, ORAS push, and then say, this is the. Okay, I'm just going to run this first. ORAS push, which says it's kind of the same as a Docker push. I just say, hey, I want to push this artifact to my registry. I want to give it this name, so it's of this tag, this name, the reference to my registry, and then the artifact in there with the demo tag. The type of it is, in this case, readme example, and I'm referencing my markdown file. So when I go back to my registry here, and I refresh this, I actually have my ORAS example here. So now I've just created an OCI artifact out of something simple as a markdown file. What I can do now is everything I showed you before, sign it with cosign, create build provenance for it, or create any other type of cryptographic signature that I want to add to this file. I can just do it by making an OCI artifact out of it. I can prove it by just signing it again. I'm not sure if that's the most feasible demo, but let's see. Yeah, I want to sign it again. I want to log in to create the authority. And then when I go back to here, and then I'll see my demo stuff have a referrer, should have. I'm doing this way too quick. Oh, okay. I have some kind of digest missed. Okay. I guess you should believe me on my blue eyes that this actually works. Great. Otherwise, we're not going to make the end of the presentation in time. So we've now seen the producer side, the producer's perspective of generating evidence, but that's only half the story, right? On the other side, we have the consumers that actually need to check the stuff that we create. Otherwise, if nobody checks it, it's just some documentation that no one likes to update. And the SLSA framework also describes the consumer perspective in this. So on the one hand side, the first step they say is please check the SLSA build level. In the build provenance file, the actual build level is added as well. So what was the level 1, 3, 2, or 3, at which this provenance was generated. What you can do is, if you, for example, if you're only on level 1, you can say as a consumer, yeah, but there's so much risk in allowing an artifact that's created only on level 1. I don't even want to bother putting it in. I only accept stuff that's built at a certain level, maybe level 3 only. And the second thing that you can do, so we've established, okay, I want to accept this artifact. I accept the risk that comes if it's not at level 3, or even if it's at level 3, which we'll see in a minute. But let's check some expectations from that. I showed you that there's all kinds of information in the provenance file about how the artifact was created, but we can actually check on that as well. So going back to here, and that's the sort of almost the final demo. Where is my terminal? There it is. So just gonna send this out and then I'll explain what it is. So in this case, I'm using the GitHub CLI, for example, because and it's failing because it's not able to load my digest, which I'll check in a minute. So in the first thing I want to check is, hey, is this artifact being built from the repository that I expect it to be from? Right, which is a rather easy check. I want to check if the certificate that's being used to sign it is from a certain identity. Right, I want to deny any self-hosted. What I said, self-hosted is on level 2, and if you're only using isolated runners, you're on level 3. So perhaps you only want to allow isolated runners. So yeah, by using the GitHub CLI or SLSA verifier is also a tool that you can use for it. You can verify all the claims that were made in that provenance file based on the stuff that you accept or not. So it's not really a golden path where I can say you should always do it this way, because it really depends on the stuff that you're using and the stuff that you have by hand. So I'm not sure why this is failing. Also not going to figure it out for now. If you want to see it working, please come after, then I'll try to figure out, debug it, and show you that it actually shows that it's working. So who is a .NET developer here? Great. Who's never installed a NuGet package before? Great. There's an issue with NuGet packages, at least pulling NuGet packages from the public NuGet feed. Because, and it's been open quite a while, since 2024, because when you as a producer upload a NuGet package to the public NuGet feed, there is this magic thing that happens where Microsoft, NuGet, whatever, actually makes some changes to the package that you upload, right? You get this author, signer stuff, but to do that, they have to make certain changes in the artifact that you upload. So the digest that comes out of your build, the artifact that comes out of your build that you push to NuGet, has a different digest than the stuff that you actually pull from the NuGet feed. So validating build provenance solely based on the stuff that you pull in from NuGet is not possible, because they alter the package that you push. So yeah, it has different files. And I hope I added this for tomorrow. Yes, great. I'm giving a session tomorrow as well about NuGet, about the .NET supply chain. So there we're going to dive a bit more into what are the risks of using NuGet packages, how you use it, all kinds of magic stuff that's already present in the .NET SDK or in NuGet that you can use to protect yourself against all kinds of threats. So if you want to be even more scared than you are today, let's meet up again tomorrow. But making this more concrete. So I've showed you as a producer that you can create provenance, you can create all kinds of claims and connect them to the artifacts that you put in. But how do you make this more feasible, more in reality, right? We as a platform team have created a promotion model for artifacts in this case. So there's actually four steps in here. So the first step is sometimes we do it ourselves, sometimes we use external sources for that, but we are building and attesting artifacts. Right? Like for example, the Terraform stuff I showed you. We are also now investigating a bit, like for the machine learning models that we're using. Should we first build them, add provenance to them, and then put a certain verify pipeline in there that verifies if the signature is correct, all kinds of stuff that we do to verify that the claims that the producer makes are feasible. But we do this also as well for all the stuff, right? Like we deploy Cert Manager, for example, in the clusters that we run. Right? Cert Manager is a tool that you can use to generate certificates from. We put this at the same test. Before any tool, artifact, anything that is allowed to be consumed by at least the mission critical part of the Dutch railways, we put it to the test by just pushing it through our promotion model. So NuGet packages, Java packages, any tools that they want to use are first cleaned entirely and verified that they are actually the tools that they want to use before we put it through. So what's a really cool thing, and it's not rather that new, but I've heard it from it quite recently, not quite recently, but not that long ago, are hardened images, and in this case Docker hardened images, but there are other, like Aikido is here for I think as well as a sponsor or so. They provide certain types of hardened images as well. The hardened images are images that are published by Docker or other organizations that do it, and they are hardening that image. So they, I'll show you. So any tool that someone's using pulling today from Docker, just scream one. Which one are you using? Node Slim. Okay, let's have a look. Hardened images. Node.js, is that okay? Yeah. Cool. Node.js, hardened image. This is sorry, before I go in, it's the Docker Hub hardened image section. Node.js. So what they are actually doing, and this is really, really cool, I think. Just gonna pick a random image here. They provide all kinds of information which the default Node.js package doesn't really provide for you, but what Docker does. So they provide, for example, an entire overview of all the dependencies that Node.js in this case has, and that are present in the container that you're pulling in. So in this case, you can check, for example, hey, are there any licenses that I might not want to use as an organization or whatever. And what's really cool, they look for vulnerabilities as well, which we're going to talk about a lot tomorrow. And the attestation. So stuff that I showed you today are it's not just something that you as a producer can do, but Docker is also helping you with it, because you can, for example, if you see there are, let me see, the build provenance. So stuff that we talked about today, but there are much more attestations that you can think of. Let's say, for example, hey, there's a secret scan done. Is this readable? I'm not sure. Let me zoom in a bit. So there's this secret scan done, and the results of that are attested to the container as well. So people can verify there are no vulnerable secrets or any secrets exposed via this artifact. Or a virus scan is done. A list of known CVEs is attached to it. So all kinds of information that you as a consumer want to know and want to verify before you put an artifact in your environment, before you put it to production, you can actually do that by using the Docker hardened images. Someone who has heard of this hardened images and used this in this way as well with the attestations and provenance and that kind of stuff? I saw one person nodding, I think, so at least you learned something new today. That's cool. Great. I showed you that. So I told you that we create certain, as a platform team, we create certain packages, certain artifacts that we distribute, we sign, and do all kinds of things with that consumers can actually, workload teams can actually use and verify that it's from ours. Another thing that we do, and that's something we use Open Policy Agent. An Open Policy Agent is a tool that you can create policies with. So in this case, we say, for example, we use gatekeeper in this case, which is the Kubernetes implementation of Open Policy Agent, or who uses Open Policy Agent. And what you can say is that when you deploy a certain artifact or container to Kubernetes, I want to do certain checks for it. I want to that certain policies that needs to succeed before I can deploy it to production or any environment. And a cool new thing, which is experimental, but we're investigating and looking into if this is something we want to use, is the artifact attestation Open Policy Agent provider, which ties into the external data feature of Open Policy Agent, which allows you to, that JSON I just showed you what the build provenance was, you can, with this provider, the Open Policy Agent can pull that from a registry and then does all kinds of checks based on that JSON file. So we're now experimenting with, we only allow you to deploy to our environments, to our mission critical environments, if you have your build provenance attached, if you have your SBOM, your bill of material generated, if you have your CVE report in there and there are no vulnerabilities, no known solvable vulnerabilities. So this allows us to do much more gatekeeping based on all those attestations as well as a platform team. So to wrap it up, what I think is most important and what makes security fun for me is that it should be automated, observable, verifiable, and most importantly, developer friendly. I'm not sure if there are any security persons in here, but at the Dutch Railways we have a security department that is kind of old school, I would say, where they say, hey, this is only secure if you give me a screenshot of this in some kind of Word template that I'm giving you, and if there's any deviation from this template, it's not secure. Right? That's what's happening. I see a lot of some people laughing, so I think that's recognizable for a lot of people. Please don't. Please use the automation that we have. Please use the tools that we're having today, and upgrade your security posture based on that. To wrap it up, and to completely wipe my story under my feet, because when I prepared for this talk, I was doing some research and I looked into this Megalodon attack, which I showed you at the beginning, which is part of, everyone has heard of the Shai-Hulud attack, right? Great. Which was the first wave, has happened somewhere in the end of April, beginning of May. And what I discovered, what's really just wiping my entire story, sort of, is that with this mini Shai-Hulud attack, there is this first supply chain attack that actually produced the cryptographically valid SLSA build level 3 provenance. So going back to GitHub, for example, they claim to be authentic, unforgeable, to create authentic and unforgeable provenance. Attackers are getting more and more sophisticated, extracting, for example, the private or keys that you use to sign your provenance with, they are able to recreate it as well. So this is just another layer on top of the security that we have. But yet again, like a month ago, they were able to to crack it. So there's this new challenge for the framework that needs to evolve and think of new ways to make this more secure as well. And then the Megalodon attack, which happened, also allows the SSA keys extracting, OIDC token extracting, source code extracting. So everything that you're doing in your supply chain might be compromised. That's maybe the total abbreviation of this. Great. With that, I want to thank you for listening today. If you're inspired, scared, or just want to have some questions, please feel free to ask. I'm here all day and tomorrow morning as well in room 5, I think, to talk about NuGet and all this scary stuff that's happening over there. So thank you for your attention. And if there are any questions, I see someone with a microphone standing by.